Let's study the interference of sound in Seeback's tube. Seeback's tube is basically an apparatus used to find sound velocity in air and used for demonstration of interference. There is a long hollow tube in which one side is open and on other side there is a piston. It is a movable piston which can be moved by displacing its shaft. And in between somewhere there is an opening through which a detector can be placed or a funnel can be connected just for listening sound interference by human ears also. And say when a tuning fork of frequency NF is brought close to the open end, the waves are longitudinal waves are started which propagates, and one wave is directly approaching to the opening and other wave is reflected from the piston and comes back to the opening. And in this situation the two waves produce the effect of interference in the ear. Now say if from the point of opening the distance of piston is L, then we can say while reaching the opening or reaching the human ear, the path difference in the two waves will be 2L, because one wave is directly reaching, another wave is traveling an extra path of 2L for reflection from the piston. So we can say in ear or the detector, path difference in the two waves 1 and 2 can be written as 2L. Now the piston is adjusted up to a position where the ears can detect a maximum. So we can say initially piston is set for maximum loudness, and maximum loudness is corresponding to constructive interference in the two waves. This implies the path difference, which is 2L, it can be written as n lambda. As we know well that constructive interference takes place when path difference is a multiple of lambda. Now the piston is further moved gradually, say by a distance x, to which again a maxima is obtained, because if we slightly displace it, the path difference will be altered and loudness of sound will go down. So we can say now piston is pulled out gradually so that next maxima occurs. For this, if it is displaced by a distance x, we can say the new path difference will be twice of L plus x, and here we can say the new path difference will be twice of L plus x, and it should be equals to n plus 1 lambda, because next constructive interference will occur again at next multiple of wavelength. Now from this equation 1 and 2 we can see if n lambda is 2L, n plus 1 lambda is L plus x. This implies we get the value of lambda to be 2x. If we get the experimental value of wavelength of sound in air, we can find out the sound speed as, in this situation, sound speed can be given as n lambda, which can be written as 2 nfx. That will be the result we obtain for experimental speed of sound in air. Frequency of tuning fork is already known to us. Wavelength we have calculated experimentally. Multiplying the two will get the speed of sound in air.